In section 4.5, we're going to talk about quadratic equations. Specifically, we're going to look at zeros and how to solve quadratic equations. Whenever a graph of a function, f of x, intersects the x-axis, f of x, or our output, equals 0. Basically, we're just finding our x-intercepts here. On the graph, where this graph, f of x, crosses the x-axis, is an x-intercept. A fancy word that we call this, or a nickname, is we call that a zero. A value of x where f of x equals 0 is called the zero of a function. To find the zeros of a quadratic function, let's say we have an equation in standard form, f of x equals ax squared plus bx plus c. Since we want to know the solution where f of x equals 0, we're going to set the whole equation equal to 0. We're going to change f of x to 0. So whenever we see something like that, we see a quadratic equal to 0, we're going to try to solve for it and find values for it. Going along with this is the zero product property, which is going to be helpful when we're solving for the factored form of an equation. If the value a times b equals 0, then either a equals 0 or b equals 0, because as we know, if you multiply anything by 0, it's going to make the whole thing be 0. For example, let's say I have the equation x squared minus 5x plus 6, and I want to know the solutions of it, which is why it's set equal to 0. Something that I'd want to do here to start is I want to get this into factored form. So using my AC method, I want two numbers that multiply to give me 6, add to give me negative 5. Thinking about that, if I want two numbers that multiply to give me a positive but add to give me a negative, that is an indicator to me that I need to multiply together two negative numbers. In this equation, negative 2 times negative 3 will give me positive 6, and negative 2 plus negative 3 will give me negative 5. From here, I'm going to split this into factored form. X minus 2 times x minus 3 equals 0. Going with the zero product property, I could call this A, this B, either x minus 2 equals 0 or x minus 3 equals 0. If I can get something in this parentheses to equal 0, it's going to make the whole thing be 0. So how I'm going to split this up is I'm going to say either x minus 2 equals 0 or x minus 3 equals 0. From here, I have a simple algebraic equation. X equals 2 or x equals 3. If I plug either of these two solutions in, it's going to make the whole equation equal 0. You don't have to write this down, but just to show you how that would work, let's say I want to try 3. If I plug 3 into this original equation, 3 squared minus 5 times 3 plus 6 would equal 9 minus 15 plus 6, which will in fact give me 0. The same thing's going to turn out if I plug 2 into this as well. The other way I could find zeros is by looking at a picture or a visual, by graphing. Here, I have the equation 2x squared plus 7x equals 15, and I want to find the solutions of it. So in this one, before I solve anything, I'm going to have to manipulate this equation a little bit. Again, if I want to solve and find zeros, I need to have the whole equation equal to 0. So how I'm going to do that is I'm going to move this 15 over by subtracting it on both sides. So I'll be left with 2x squared plus 7x minus 15 equals 0. From here, if I want to do what I did in the last example, I could factor, but another way I could do this is by graphing. So in my graphing calculator, I'm going to go into graphing mode, and I'm going to plug in this equation that I just got. 2x squared plus 7x minus 15. I'm going to plug that in, and on a graph, I'm going to see I get something like this. My zeros are where I cross the x-axis. So if I look at my graph, I'll see that I have zeros at negative 5, and I also have a 0 at 1.5, and those would be my solutions.